So here we go. So inequalities and word problems. So things change a little bit when we deal with word problems. When given a word problem, you will need to read and interpret the question in order to produce, okay? You're gonna have to create or produce the appropriate inequality or inequalities. An inequality essentially provides you a restriction, okay? An inequality is essentially a restriction to possible answers. A couple of things to keep in mind. So if you are dealing with, you can be dealing with discrete or continuous data. And when you're dealing with discrete, you want to round your points of intersection. Okay. Discrete, what is discrete? I call that things you can count. You're counting how many you have of certain items. Okay? So you can call it, right, coins, people, cans, etc. Okay? Continuous, things you can measure. Okay, so length, volume, temperature, anything that has like centimeters, millimeters, inches, anything that has that you can measure is this continuous. So it's okay, right? It's okay to keep decimals. So for example, here, if you deal with discrete data and you get 6.91 4, let's say, yes, I want you to write it down, but then we're just going to say, well, that rounds to 7, 4. Okay. That's all. That's just a little, that's like a half mark thing there. I'm just going to scroll down here. Almost all cases involve data that cannot be negative. That's important here. Therefore, your graph will be restricted to quadrant 1. Okay? So the question will not explicitly say it. So that's why we say there's an implicit constraint of x and y being greater than or equal to 0. Or, if you don't want to state it like this, you can just say x is greater than or equal to 0. Y is greater than or equal to 0. You essentially add two inequalities to the mix that get rid of all the negative values. Okay. It's almost like if we had this, remember, if x is greater than, where is the true region? To the right. Sure. And we would shade left. We would shade the false regions. Okay, let's keep going. So, no context. If it's not a word problem, it all goes. Right, here's your solution region. You have just one POI. Because we are interested in the boundary lines and where they meet surrounding your solution region. So there you just have one POI. If it's a word problem, we're going to try to copy this, okay? So notice that this line right here goes between 20 and 30. So we're going to somehow make a point right there. And then this line is at 20, 0. It goes right through here. So let's make that solid line. This solid line, we copied it over. So just go halfway between 20 and 30. Make a point there. Go straight to 20. And the dashed line goes, just count one box up from 10, goes through there, and it goes through 40, 0. So go to 40, 0 over here, and let's connect those two dots. So that's a dashed line, of course. And let's shade accordingly, right? So the dashed line, everything above it is shaded. The solid line, anything below it is shaded. However, stay within the quadrant. And here your solution region is that. So it's basically this wedge here, this little wedge. And now you have 1, 2, 3 POIs. So essentially the x-axis and the y-axis become a boundary line when it's word problems. So the intercepts are now, right? The x-intercepts in this case are POIs. Similarly, if the solution were to be here, then the y-intercepts would be considered boundary POIs as well, because the y-axis acts as a boundary line, right? So that's all I'm going to say here. 3 POIs. There was only 1 POI here, so that's how it's different. Context means word problem. And you know what? It happens every year. So I'm just going to say it. Lines stop, right? So don't continue the lines, the boundary lines. I will also go over here and just make an arrow going to that, and make an arrow going to that other y-intercept there. So lines stop, highlight that, and I hope that when you flip through your notes, you will account for it. Okay, so now let's practice writing inequalities. Let's keep going. Next page. Writing inequalities. So I've got a couple of key words here. These are important. You're not going to see is equal to. You're going to see other words, right? Up to, maximum, no more than, has a capacity of, at most, okay? Or you'll see at least, a minimum of, etc. Those get the greater than or equal to. All of these keywords here get a less than or equal to. But I will do this. I do this every time. Keywords. Shortcut. I will say go page 48. I think there's a blank page there. Let's go to 48 real quick. And we'll just do this. This is for your study sheet. Writing inequalities. This is on 48. You will use less than or equal to if you see the words up to, at most, maximum of, capacity of, holds up to no more than, then you use less than or equal to. You will use this inequality if you see the words at least, minimum of, no less than, obviously greater than, so those are some keywords there. If you see those, right, you know which way your inequality is going to be pointing. And so I would add this to my study sheet, just make sure there it's not as big as this. And then you know the keywords, and if you struggle with it, at least then you know how to do it. Good. Back to 42. Let's practice writing our inequalities. Write the inequality for the following statements. I'm defining the variables. Let x be the number of people and y be the number of pets. Just make a note here. Discrete data, right? Because number of people, number of pets, you can't have decimals of, right? You can count them, but you cannot measure, okay? Another thing to, you know what, I'm going to do it the shortcut way because I'm a little lazy today. This is the one I prefer. This is what we call the implicit constraint. The implicit restriction. When someone is telling you explicitly to clean your room, they're telling you straight on, like, you know what, clean your room. If somebody is implicitly telling you to clean your room, they're hinting, but they're not being. So this question is hinting towards this, okay? Can't have negative pets or people. Anyways, let's say you have a statement that says a building can accommodate no more than, that's important, that's a hint for inequality, no more than 400 people. It doesn't say exactly 400 people, it says no more than 400 people. And since people represents x, how we would translate this would be x has to be less than or equal to 400. A dog park can hold up to 45 dogs. Can hold up to, that's an inequality right there. We're talking dogs, so we would go y is less than or equal to 45. So we're saying, based on this statement, you're saying that y has to be less than or equal to 45. It can go right up to 45, but it cannot be more. Okay? A dog park can have up to 100 dogs and owners combined. Dogs is y. Owners is the people, right? So you've got both in the mix here. So you will say the way you translate this is the number of owners and dogs combined, use plus, okay? Has to be less than or equal to 100. A vet can see up to 24 pets per day. So if we're talking about pets exclusively, then we would say y is less than or equal to 24. Next, a committee needs at least 5 members. We're assuming people. Could you have a dog or pets in a committee? I guess you could. But in this case, let's assume we're talking people. At least 5 people. So X is represents people, and you want the number of people to be at least 5. So whatever X is, has to be 5 or greater. A stadium allows up to 20,000 visitors and pets combined. So this is people and pets, right? So obviously this is our Y, and visitors would be the X there. So in this case, you go X plus Y has to be, that combination has to be less than or equal to 20,000. This ends there, right? So this is a different question now. So another example. This can also be applied to just numbers. 2 numbers have a sum that is less than 20. How would you translate that? 2 numbers. Well, before you do this, you let X be the first number, and we let Y be the second number. You have to define your variables. Question, is this continuous or discrete? These are just any numbers, right? This is just numbers. So this is continuous, right? So there's no word problem. If there's no word problem, it's continuous. Well, it sort of is a word problem, but we're not restricted to number of people or number of items or anything. So this is continuous. And anything goes. Anything goes. There's no implicit restriction here. So 2 numbers have a sum that is less than 20. I go X plus Y have a sum that is less than 20. So you can't have the equal sign there. And then it says twice the first number plus 5 times the second number is at least 50. Twice the first number plus 5 times the second number is at least, meaning greater than or equal to 50. Could you graph those two? Absolutely. You should be able to graph those 2 inequalities if I asked you to. But right now it's just about writing the inequalities. All right, keep going. I wanted to make a note, actually, sorry. I know, you're jumping. This scenario spans all 4 quadrants, okay? So in a sense, X and Y would belong to the real numbers. Like it's just all numbers, negatives, positive, decimals, everything goes. This is not a word problem. Let's keep going. Steps to interpret, graph, and solve problems. You know what? I might pause here for a bit and ask you to write inequalities. Let's put 43 on hold for a bit. And let's go to 44. Actually, I'm sorry. I know I'm skipping a bunch. 46 for now. 46. So if you go to 46, I want you to simply go at the top here, write inequalities for each example. And remember, I don't expect you to ace this right now, but I think I want you to navigate this a little bit. So I'm keeping it very basic. There's not a whole lot going on. There'll be more going on later on. So, but let's say that the first one, a company makes motorcycles and bicycles. I will let X be the number of motorcycles. Y is the number of bicycles. I think we would all agree that we cannot have negatives here. So this is the implicit constraint. And it says they make no more than 400 vehicles in a week. Question, or what you need to ask yourself, this number 400, is it specifically talking about X, Y, X alone, Y alone, or is it talking about combined? It's combined. So in this case, it's this company can make no more than 400 vehicles. So the combination of both of them has to be less than or equal to 400. That's it. That's all I need you to do for these examples. Okay? So go through 46 and 47 for now and just write your inequalities. But I want you to go through the steps that I went through. Define your variables, implicit constraint, which is going to be the case for all of your questions here, by the way, and then write the inequality. Every scenario just has one inequality. Okay? Or not. I shouldn't say that, actually. It could be that there's more than one inequality. So I'm gonna add some curveballs, or maybe some alternative examples, just so you can differentiate when to use what. Okay. Question 2. Sam wants to spend up to 10 hours studying for her math and science exams. So here you have to be somewhat careful. Some students would just say math and science. But what? Time, right? Time spent. So you can go math hours. I'm okay with that. Science hours, like the amount of time you spend per subject. That's what X and Y represent specifically, okay? So you would say you have up to 10 hours studying for both of them. So you just go X plus Y up to 10 hours. So that combination has to be less than or equal to 10 hours. You could go 0 and 0. You haven't lied, right? You haven't surpassed the 10. You can go 9-1, but you can't go 10-1. That's 11 now, right? So you don't have more than 10 hours available. I did tell you, right? I may not be mentioning this every time, and in this case, it would be continuous. Continuous data, so because you can have decimals of hours, okay? Let's keep going. Oh, there. This is where it changes a little bit. I don't know, maybe you didn't catch it, but a dealer can purchase touring cycles for $300 each, racing cycles for $400 each. She plans on spending no more than $8,400. This is where your inequality territory sets in, that no more wording, okay? So in this case, you let x be number of Turing cycles, and y would be number of racing. Okay, x and y cannot be negative. And this is what, discrete or continuous? Can you measure a bicycle? Well, I guess you could, but in this case we would say we're counting, right? We're like figuring out how many. So this is discrete. That comes in handy later when we do the points of intersections. That's why I want you to start thinking about it. And in this case, you can't just go x plus y is less than or equal to 8400. Why is that wrong? I want you to think about why this statement right now is wrong. If I were to translate this back, you're telling me right now that you cannot sell more than 80, or you have to sell less than or equal to 8400 cycles altogether. That's what you're saying with this statement. So in this case, you have to use, because we're talking money, you have to use the 300 in front of Turing cycles and the 400 in front of the racing cycles. Now you're saying if you figure out the number of cycles, you can figure out by multiplying and adding how much you've spent. And the amount of spending is less than or equal to 8400. So that is important, that you have the coefficients there, not just 1 and 1. Okay? Let's put a note here if you have room. Note x plus y is less than or equal to 8400 would read, okay, the dealer produces up to 8400 cycles combined. So this to me is a good, I always like counter examples. Sometimes you learn better with like common error examples than to just how you do it, right? So that would be wrong. Okay, keep going. $47. Every question has a little bit of a curveball. One cake requires 150 grams of flours, while a different cake requires 75 grams of flour. You can do cake A if you want. If they have two different, I call one A and the other one is cake B. Requires 75 grams of flour, sorry. At most, 2.25 kilogram of flour is available at most, right? That's the most you have. So here, I will let X and Y be something. So I think most of you would say, or be inclined to say, oh, well, this is what it is, cake A, cake B. But in this case, we're talking about flour, right? Like how much flour. So you have to say in grams, right? Grams of flour. Oops. Grams of flour, and this is also grams of flour. Okay? And then you let X and Y be greater than or equal to 0. In this case, it's continuous because we can measure the amount of flour, right, in grams. So here we go. You will use 150X, right, 150 grams for the first cake and 75 grams for the second cake. That has to be less than or equal to, there's a problem here. I don't know if you caught it. Did you catch it? Grams, grams, kilograms. Okay, so we just have to go 2.25. Do you remember this? 1 kilogram has 1,000 grams. Cancel that out, so it's 2250 grams, okay? So you gotta have everything in the same unit, or else you're saying that combined you can't have more than 2.25 grams, right? Like it's contradicting. Yeah. It doesn't matter as long as the number goes with the right variable. So you have the 150 in front of y, and vice versa. What did you label your x and y as? That would depend on. So the way I would read your question is that you're saying that the first type of cake, I think you'd be fine if you defined your variables correctly. So it does matter in a sense, but did you define your variables? So for today you're kind of fine, but on a test or quiz you wouldn't be. You have to define. I will sometimes define them for you, but sometimes you have to define them for me. So it does matter. Depends on how you label it. Okay. A bakery can make no more than 600 muffins and bagels in the morning. This is just a classic. I'm just going to go right to it here, okay? Bagels and muffins have to be less than 600. That's it. There's just 1 and 1. No other coefficients needed there. Down the road, they'll mix it up on you. Okay? For example, I know I'm jumping. That's just how I roll sometimes. But this same question could have had another statement. In addition to that restriction of flour, the bakery, to make enough money, has to make a combined of 500 of the two cakes combined, right? At least make 500 cakes combined. How would you write that? You go x plus y is greater than or equal to 500. So you would have another inequality in that same question. Let's keep going. One type of shelf has 2 brackets. I'd call this A. Another type of shelf has 3 brackets. A total of 42 brackets are available. So when it says available, it says up to, okay? You have up to that much available. That's what you want to think about there. So I'll say x plus y, 2x plus 3y has to be less than or equal to 42. That is the answer for that one there. And then we've got downhill skis for 200, cross country for 150. Her order cannot exceed 6,200. So in this case, you go 200x plus 150y, provided that x is downhill, y is country skis, cross country. Then it's less than or equal to 6,200. That would be the inequality there. Okay. So I hope you kind of get the gist of it. Where am I at here? Let me go back a little bit. We're going to beef it up on you a bit here. So I want you to go to 44. And I want you to go from 44 to 45 and just write the inequalities. Okay? Page 44 to 45, write inequalities. I'm not asking for a whole lot, because I'll tell you this, if you know how to write your inequalities, graphing and all of that, we've done quite a bit of that. Okay, we've done graphing. So the challenge now will be is to write the inequality and write them correctly. Okay? So you have the rest of today's class, which is about 14 minutes, to do just that. Read carefully, give it a try. I will post the answer key so you can check right away if you want. But first try giving a go, okay?